Hey everyone, welcome back to quantprof. Today we are going to solve a Citadel quant interview problem. Check the description for more quant interview resources. 6 points are chosen at random along the circumference of a circle. Depending on how they're placed, they can form different configurations. We want all the points to lie within a semicircular arc. For example, in this configuration, they lie within a semicircular arc. On the other hand, in this case, they don't lie within a semicircular arc. So what is the probability that all 6 points lie on a semicircular arc? Pause the video here if you want to give it a try. Here's the solution. Let's label the points as A1 through A6. Let EI represent the event that all points lie on a clockwise semicircular arc starting at point I. For example, this configuration satisfies the event E1 as all the points lie on a clockwise semicircular arc starting at point 1. However, in this case, even though all the points lie within a semicircle, they do not satisfy event E1 because they do not lie on the clockwise arc starting from point 1. Note that the events EI are mutually exclusive, meaning that at most one of the events can occur at any given time. For example, this configuration satisfies the event E1. However, it cannot simultaneously satisfy event E2, as the clockwise semicircular arc starting from point 2 cannot include point 1. The points will lie within a semicircle if any one of the events E1 through E6 occurs. Therefore, the required probability is the probability of the union of these events. Since these events are mutually exclusive, the probability of their union simplifies to the sum of their individual probabilities. Alright, let's calculate the probability of the event E1. Fix the first point here. Each of the remaining 5 points must lie on this green arc. The probability that the second point lies on this arc is 1 by 2, and the same holds for each of the other 4 points. So the probability of the event E1 is 1 by 2 raised to the power 5, which is equal to 1 by 32. Similarly, the probability of any other event EI is also 1 by 32. We have shown earlier that the required probability is the sum of the probabilities of all these events. So the required probability is 6 by 32. Let's consider another problem. We randomly draw 6 chords in a circle by selecting their endpoints independently along the circumference. Depending on the configuration, the chords may or may not intersect. For example, in this case, some of the chords intersect. However, in this case, none of the chords intersect. So, what is the probability that no 2 of the 6 chords intersect inside the circle? Try to solve it on your own. Hope you liked the video. If you want to learn how to solve these kinds of interview problems, we invite you to check out our course, Quant Interview Masterclass, where we teach you how to think when solving difficult problems. We also cover the entire theory, specifically tailored for quant interviews, along with over 1,000 problems. Thanks for watching and see you next time. Until then, Godspeed.